Okay, we will slowly start. We'll check with the live audience. So you can press like if you can hear me. Press like if you hear me. Right? That's a joke. But if you can also write plus minus. Right? So if video audio is okay, let me know. Yeah. So we'll start by looking at the some of the submitted homeworks and things like that. And if you didn't manage to do this till this session, you can try to do this till the next one again, because there was a short notice this time, which I understand. Just a second, but because this week we have large conference in Riga on Thursday, Friday. Would not be able to run the election other time, but then we can also already tell that next week we'll do the election on Wednesday on 4 o'clock probably, but we'll double check. If somebody is not able to join, then you can join in YouTube live. I myself in person will be probably in Riga on next Wednesday, but those people from here from Ventspils can join live. But I will write this in the proper communication channel, so those people who are in Riga will welcome to join in person. Would happy to meet you. We'll write in which place, and we will start working with proper neural network models next time. But this time we'll keep working with the basis that we need mathematically and programmatically, right? And yeah, so let's wait maybe a few minutes just for somebody else to join. Just a second. Yeah, please follow the time schedule. I know this is a little bit chaotic, but this is the only way how I can do this. Unfortunately, it's like I have other responsibilities, and otherwise I would not be able to do this at all. But at least hopefully people could appreciate that this material is somewhat useful. So we'll see. Okay. Okay, so let's look at some of the, so I will do the full screen here. Let's look at some of the examples of the homeworks. Again, if you did not manage to do this, do it later, because then you will better understand things. Okay, so here's one implementation of full game. We'll see how well it works. Hopefully it will not crash my computer. Okay, great. It looks fantastic, actually. It looks much better than I expected. Oops. So it's a bit interesting how it rotates. Doesn't feel right. But maybe it's skewed somehow. But it looks amazing. So also really interesting. Oh, this is like a the satellite around the spaceship. That's cool idea. That's cool idea. But otherwise, yeah, right, I'm starting to understand which one's, oh, right, I can even shoot things. That's very creative. That's really cool. We'll look at a little bit on mathematical side, because, okay, now I start to see, okay, right, I was expecting a little bit different type of triangle. That's why I'm confused. Can I shoot my own satellite? Let's see. It's so smooth. I love it. So good job. We definitely give extra points for this. This is really nice. Super good job. So this is what we want everybody to achieve, right? So, some level of effort as well, not just execution in basic matter. Okay, so what we see here was something I mentioned last time. Try not to make in functions multiple returns. If the function is really small, then I don't care. But normally functions tend to grow very large. And so you start by 3-line function and then you end up by 100-line function, and then this return will kill all of your code sometimes. So it's always better to have one input, one output of the function. And also, actually, these kind of operations are highly not recommended to do in the return. So basically, you should do things in this manner. So result, and why? Because if it fails, you would be able to debug it much easier rather than if it fails there. Plus also, we could rewrite it basically like that, and have it something like that, right? So small things, but it builds up later. Like you think this is stupid, but later you will see that at some point this will bite you. Like if you not pay attention to small things like these. So it's again just the coding style, but nothing much. So okay, there's also so in Python it's highly recommended to do this, like to just try to do more tabs, more enters, and make code readable. So not try to make long lines, right? So this is definitely something advisable. So rotation matrix around Z, right? That's interesting. Did we have the wrong rotation matrix? Because I think it was already around Z. Anyways, yeah. So you can rotate, of course, around any axis, right? So okay, so here's the T. That's cool. Okay, there is a simulation of gravitational force again. This is not recommended way of doing things, especially for case if okay, this will, yeah, if it fails, then it's very difficult. So it's definitely not recommended to have this kind of structure. Okay, so there is a drawing circle. Okay, and this is I think this is made using 8 octants. So this is the hard way. So this is excellent job. If you did this hard way, it was not just the simple line drawing algorithm. So this is excellent. And okay, also not recommended to do something like this. So this is starting to become like the spaghetti code, basically. So spaghetti code also will bite you. So if you start doing this in some kind of like more complicated mathematical equations, you will end up by very hard debugging. So better to have multiple variables, better to make it more code, but clearer. So I see that there is used Pygame clock. So let's see how this. So this is written basically clock tick. Okay, so this makes it, I guess, smoother. So the clock tick is similar to what I tried to attempt previously with the delta time, because it just measures the time between the frames and tries to maintain the same frame rate between the frames. So maybe that's a way to go as well. Yeah, really good. And what about the game over and things like that? How this was implemented? There's some kind of game state, I guess. Yeah, so usually in the game, so this is definitely not related to our course here, but in games you don't do this, game, win, and so on. You just have one state, like state enum like running, enum win, enum lose, enum menu, and so on. And then from the state you can easily choose which screen to show. But otherwise, like really good job. So this is good. So here another implementation. You can try to run it. Okay, this is, I guess, the same implementation with the less detail. So there's the rockets. I believe this is from the same person, basically. And I believe this is made by different circle algorithm. Circle. Oh, this is implemented in a strange way. Draw planet. Was it implemented in there as well in that way? Right. I did not notice this, but this is not totally cool. Ship. Yeah, so this is the kind of hacky way. So I don't want you to actually, for others to do this. Please don't use Pygame Draw, because what we want to show here is that you can operate with matplotlib. That's why it was so smooth, because it was not drawn with matplotlib, I guess. Matplotlib, I did not notice that. Yep, it's not matplotlib. So, but matplotlib is just a mathematical plotting library, but basically using that library you can operate with raw vectors and achieve the same things as here, like draw a circle, draw a polygon, and so on. So this is what we actually want. Okay, so let's see. So here's another example how to draw a circle, except would be nice that this would be part of game. So why you can run it, okay. Okay, so this is a circle drawing algorithm. And then how you would implement it in the game is that you would store, so you would have something like, let's say, so there's a circle, x, right, whoa, okay, so this is not the way how I would like to implement it, but okay, so x and y, so what I could do is vectors equals zip together these things, okay. So let's turn off this thing. So zip together these things, and then so yeah, and then I could return vectors, and then I could apply the transformation matrices and so on to these things, and this would be what I wanted to have in this session. So, and then another example. Okay, this looks more like what I wanted. So it seems to be working very nicely, okay, except we can maybe even, this but works also, rockets works, so this is great. What we could do is we could fix these asteroids, because these asteroids do, and also the planets, do not look really complete, but this is great. This is a really good job as well. So this is even, I believe, a little bit better job than the previous one, rather because this was executed manually, because previous job was made using the ready-made functions. So let's see. So if I find some kind of where is the circle, theta? Okay, there's the circle. So first, to fix the gap, I believe what we could do, there are a couple of ways, but I guess the simplest way maybe is to have equal or this. Let's see if this helps. Yeah, so there's no gaps anymore to blue ones. Okay, so this is cool. Then we can go to asteroids. Where's the asteroids? So here as well, and we can do better. So let's make. I actually wrote this in the instructions, but it seems that you did not do this. So the radius. Where is the radius? Okay, here's the radius. So what we could do, we could change radius dynamically. So let's see, radius equals self radius plus random and this was what is the radius? Okay, right, it was random like that, but we could do it even better. So random times it, so it's 0.2, then let's see, 0.2, okay, let's 0.2 plus 0, okay, if I want to have it in the minus as well, so minus 0.1, yeah, I guess something like that. And then if I run it, now I have really nice asteroids. See, only, again, they are broken apart, and I know why they are broken apart, because this would not work anymore. So what we need is to repeat the first vertice. To repeat the first vertice, I would do this, append geometry 0, run again, and now they should look really nice. Yep. So this job, actually, I would give, this would be the best homework from which we looked, but you see, like, just applying, like, literally some really dummy things, you can end up with really nice looking game, basically. So this is what I want others to also do till the next time, because not many did this. Please try to achieve this. And let's jump into the today's session. So let's see if I have some questions in the chat. Okay, questions. Yeah, so the others who just joined the course, in the Moodle we have lots of materials. You need to learn them through. Make sure that you are up to date. So, and if you submit your homework later, don't worry, we will count it. The thing about the homework is that this is for you. You need to learn yourself how these mathematics work, and also we can share the results in the next lecture. I don't like, if you will do this later, there's less value to this. Please try to do these homeworks till the next lecture. I know this time was short notice, but if you try to do this, then I can show the code. We can go through this and learn something together. Yeah, and then at the end, the main way how we will rate this course is actually using the exam. So because in nowadays when you can have GitHub Copilot, we need to have exam, otherwise I cannot guarantee that you understand what we're talking here. So that's that. So today's lecture. So okay, so now we will combine the linear algebra from the computer game of the asteroids with the partial derivatives and calculus, jeb in Latvian augstākā matemātika un partiāla atvasinājumu, to achieve the inverse kinematics. So inverse kinematics, what it actually means. So inverse kinematics is actually a course and some discipline in the robotics where you have lots of different methods. There is not just one method, but there is multiple methods you can use to not achieve this. Let's see, can I skip this? Yeah, so to achieve this, so you have a robot arm that is programmed to move around objects or hit very specific points on the space, like without any kind of problem. So this is the Robot Studio on ABB robots, and it also uses inverse kinematics. So you could do this by moving the robot to the right position, store the position, and then try to repeat this position, going from one position to another position. And this going from one to another position, this is not done in a dummy way. This is actually done in most cases using partial derivatives, which we will do today. So you could do this also geometrically, but this is then super hard-coded. If you don't want to be that hard-coded, then you use partial derivatives. And the fun thing is that if you look at how the robot arm moves, it looks very naturally. So it's not like just using the straight lines or something like that. And this will be the same thing that you will do today, basically. Using the partial derivatives or partial atvasinājumu, you can achieve this natural motion, and basically this is also a great metaphor for deep learning and the machine learning models that we have nowadays, that they also optimize the feature space using the same behavior as these robot arms. So and yeah, so let's jump in and how to do this. So let's see. If you have any kind of questions, whatever whatsoever, you can write in the chat. If you're lucky to be in the same physical location, then we can talk also in person. I will always try to be in some physical location, but unfortunately I cannot guarantee that I will always be. So we'll have some remote sessions. Okay, so. The first part, so we will have for inverse kinematics, we will have forward kinematics and we will have backward kinematics, and this is exactly the same way how in the deep learning it works. Like you have forward pass and backward pass and this will be for mathematical functions. So I will now open 3.2 task, in the Moodle. So you could go in the Moodle and pick up the task. And there will be a template as well, and we'll try to explain. So I posted it now, and what I have there is following. So I'll have a really simple robot arm from the 2 segments, and this is something that I want you to do yourself probably. Last time when we tried to do a couple of tasks, it was very difficult for this group of people, but I hope that with some tasks you will be able to do yourself. So what you have is theta 2 and theta 2 angles. So it means that there is one angle, and like there's another angle here. So 2 angles. Yeah, I guess so. So there's one is, all right, it's actually from where it's calculated -10. That seems interesting. All right, it's calculated different way. So here is the angle is from there. So there is 10 degrees here and 10 degrees here. So okay, so good. So these are the 2 angles, and we also have some transition vector. So there is a t translation vector. I meant translation vector t. Interesting. How could I make it smaller? Okay, cool. How can I copy it somehow? Let's see, chicks. Okay, I can. So there's the 2 t vectors, and you have the origin vector, which is the x, and you have the target vector or point, which is y. In this case, actually, it's a y prime, but there will be also the y, which is the, if you click around with the mouse somewhere, you will be able to produce this red dot. So, and this will be the point where the robot arm needs to go from y to y prime, from y prime to y. So, and here we start from x. We have then the point 1, point 2, which is y prime. We need to go there. So, if you open the your code, it actually don't have the whole stuff ready, so you need to do this yourself. We'll try to help if it's too difficult for you. How you achieve this is actually using some basic mathematics, right? So you don't achieve it just by manually hacking it like some person did it previously with the Pygame functions. So you use basically some values like these, some equations like these, and rotation matrix you already have. I gave you the rotation matrix. And this is, right, and this time the rotation matrix is in 2 dimensions, not in 3 dimensions. The last time we had to have 3 dimensions because we wanted to combine the translation matrix inside the equation. We could actually do this here, but then it will be even more complicated. It's easier this time with just 2D. So what's up here? Let's see. So let's annotate a couple of things. So first of all, let's make some color. So this will be, so y prime will be here, this purple point, and this is the this is the y prime. Yeah, and actually the top part, this is just a function. So this you don't need actually maybe to implement the top part. So don't implement this separately right now. But basically the top part is also important. So there is the rotation and translation, and this is called affine transformation or linear transformation. Affine transformation, linear transformation operation. So it combines the translation and rotation in one go. But please don't implement it because at this time let's focus just on the full equation. So, but this is also worth to know, but we don't need to implement it now. So the y prime part we know. So y prime is this guy, the purple guy. So this is y prime. Okay. Then we have two other points, so let's color those as well. So we have the green point, for example, this one. No, yeah, the Y prim is actually up there already. So it means the green point is here only because the X is the input. So X is the input. All right, it's actually X is missing here because the X is already 0, 0, I believe. So let's call this part as a P point or something. So this will be, let's say, P. Or it can be actually H, like hidden vector, which is more similar to deep learning. So let's look at this. So we have this this initial part. So this is the R theta 1 plus R theta 1 times R theta 2, and basically this first point is moved. Okay, right. So this green H point is located here. Basically, this is the H point. H. And the T is actually just the the length of this, and then the full Y is then when we plus the other part as well. So this is Y prim basically. This all together. So if I have the purple stuff, so all of this together is Y prim, of course. So that's about it. So it's nothing difficult here. It's the same thing as we did last time so far. So let's see if somebody has implemented this already. I will show the code, and we'll try to help with people here on the live session, in the classroom. So we'll see, because this is really not difficult at this point. So let's see the code. So we have two thetas here. If I run the code, actually how it looks like, let me share the full screen. And so this is running the code. So this is like this. So I have the point. Actually, if I click it, I can move the target point here. I have one segment here because it's not moving, because it's not implemented. If I press escape, I can close this. And I need to implement some of these very simple basic stuff. So I need to implement rotation the same way as last time, just in 2 dimensions. Then I have here the X point. Then I have the next point, which is the middle point. And then I need to have the last point, which is the, we can even, as I said before, this is not nice way to write the code. We could just write it this way, P, or H, this was H, and then will be Y prim, yeah? Y prim, like that. And you need to just calculate what is the H here, what is Y prim, using the dot product. I remember that those multiplications, those are not simple multiplications. So I can maybe start helping you out, but I will not help much, hopefully. Hopefully you can do it yourself. So let's see. So if I have rotation, all right, maybe I should calculate it already because it repeats multiple times. So R1, let's see, like that, rotation theta 1, and then rotation theta 2. Yep. So, and then this will be the R1. All right. Let's look at what is the equation. That was my equation. So the R1 at T So the right, okay, so R1 at T. So the this at symbol, this is exactly the same as np matmul or np dot. So if you have numpy array, you can do this operation and this will achieve the same result, but it will look much nicer. So that would be the first part, and then you need to do the second part, and then you need to implement here the rotation. So I almost gave you everything. Please try to do it yourself, and you'll see how you succeed. I will check if I have somebody already finished it. So right now, no assignments submitted. So let's ask in the chat. So is it clear what needs to be done? Press plus, minus. If not, I will try to explain more. And also here in the live audience, let's check. I have cold classroom here, that's why I have a coat. Maybe just a second, I will go help people. So I'll go check the people around. Tu īstenībā saprast, kas jādara?
Es nezinu, kas tas ir.
R, tā ir rotācijas matricas rezultāts. Tātad vēlreiz. So I use the how you say it, like R1 and R2 because R1 is repeated multiple times in the equation. So you need to implement this middle equation, which is taking in theta 1, theta 2, the t length, and applying the dot product to that, then plus, then multiply, then do the dot product, then do the dot product again with that one. And if you do this in the right sequence, right, if you implement this all in the code, it should appear like in that image. So you need to get that image for using these equations. So there's nothing else that I'm asking you at this moment. So let's see if others in the live audience understood what we need to do. So where's the nobody answers me. Is it not clear? Not clear. If questions are, oh right, minus, that is amazing. Right, probably that person did not do the homework, but yeah, so this is something to keep in mind. Like these mathematics will become harder and harder and harder, but basically this time this is still very easy. So you need to definitely invest your time in the homeworks, because otherwise you will be completely lost in a couple of sessions. So this is something to keep in mind. But okay, thank you for giving minus. Then I will try to explain more. Like tu nesaproti arī? Great, that's crazy. Okay, let's see. But maybe let's try to help. So okay, so what we need to do. So we have the so the initial point. Basically, I'm implementing exactly the same equation. So initial point is x, which is not defined anywhere, I believe, except maybe up here. Let's see, do we have it somewhere? X. Right, it's here, x. But because it's 0 times 0, 0, 0, it doesn't change any kind of position here. But if we would like to have it, we could add here x like that. But it doesn't change anything because it's right now 0, 0. So that is the first part. But to have it exactly like I showed in the whiteboard, we could leave it out. So then h plus the exact equation on the whiteboard was basically r1 Then at R2 at T. Yep, like that. So that's that. But again, to have it exactly like it was on the Jamboard, on the whiteboard, we could delete that part. So we have this, and right, R2 needs to have with this one, right? And then we add the points here, and what we did, we just calculated from the right angle theta shed 2 must be, yeah, so like that. So from angle theta, we calculated the rotation matrix, applied it to this translation, and then also did this for the second time here. Then what we could do, then we and the equation, you didn't have to think of yourself the equation. The equation was given on the whiteboard. There is nothing there. And the up part here, this is again super simple. This is the same as we did last time, basically. NP array. There is nothing new here. Basically, if you did the homework, this was something that is very similar to what we did in the homework. So there is the cosinus sinus. So there will be C NP cosinus theta, except let's see if this is radians. This is interesting. So yeah, maybe so this is already radians. Okay, so this is already radians, degrees to radians, so this is cool. So S NP sinus theta, and then we'll have the equation here, minus sinus minus cosinus sinus minus sinus, like that. And now if we run it, I believe we should have nice result, because basically this is all I asked for you. So if I accidentally changed my template. Excellent. I hope you saved the new file. So if I run it, yeah, I have to do another bracket here. Yeah. Run it again. It is almost good. not really good. It is something went sideways here, but we will find what's wrong. Maybe I implemented it the wrong way, the equation. Cosinus, yeah, this is wrong way equation, so that's why it's distorted. So cosinus minus sinus sinus cosinus, right. Try again. Yeah, now it looks great. So that's what we do. So we implement equations and achieve so basically some visual results here, or basically we move forward the robot arm. So we start from the X, from the base, and we move to the Y prime, which is the target location based on just two variables. So only variables we can change is theta 1 and theta 2, which is the angles of the robot arm. If we would like to have some more advanced robot arm, we could also change the length of the arm, but right now we are specifically trying to do this just by changing this angle and this angle. And if you don't believe this works, you can just change a little bit angles and test out. So if I change here 30, right, the top part should be on the other side, like that. So this works. This works, okay. So I will put some of this code on the whiteboard, and hopefully you understand what we do here so far. Really hope. If not, then probably you need to do the homework and study a little bit more, because again, I say, if you don't do this, it will become more and more complicated, but also more and more exciting, because you will be able to do more and more things with mathematics that you maybe didn't know that you can do all of these things with mathematics. So I'm adding this on the slide number 4, and Slide number 5. Let's see in the chat. Okay, somebody who is the first time need to then catch up with the previous fork, but don't worry. I'll try to yeah, you just need to watch the previous videos, go carefully through them, and not make the, you know, not delay this, because when later it will be harder to jump in. Okay, so that's that. So we have the first step ready. Okay, let's move to the second step. So this is called forward kinematics or forward pass in the mathematics, in the equation execution. So in the deep learning and machine learning, this is also exactly the same terminology. You have the forward pass and the backward pass, and this is the simplest mathematical operations, which is the forward pass. Then we have the next step. I will also immediately open the next task. So this will be how to estimate how good is my robot arm position. So if I have this red dot, right, I have this red dot, which means the location where I want to go with my robot arm. And I want to calculate what could be the, like what is the best, like if I'm moving closer or farther away, right? So I could just calculate the Euclidean distance, and Euclidean distance is actually, there is this other name for it. The other name is mean square error, or L2 loss, basically. And this is something that we could implement together. So say on return to course, I open 3.4 task and how it looks like. Let me share something. So the 3.4 task looks something like this. And I hope that that is something that you could implement yourself, because that's maybe even more simpler than the previous task. So what you need to do is to have the plot, like this dialog that you see, this window, to have the loss value. Loss means the error. Basically in the machine learning, you always say loss, not the error. So, and here this is the loss equals some value. And this value is calculated using this formula, mean square error or Euclidean distance. Please, again, don't use the built-in functions. So you have the y prime and you have the goal y, and you need to calculate the loss. If you will have the like perfect position of the game, you will have loss 0. If the position is far away, you will have loss high. So again, just for everybody to understand what I'm asking from you, again, this is extremely simple. Let me show you. So here, if I run the code and I drop this red dot, so now if I drop it here, this should be loss 0. It should be written on the top part. Yeah, I can even show you where it should be written. So there is a tet, here is the loss equals, and if I use these brackets, it is string literal, yeah, loss. Let's see if I don't have it defined, so I can define it here, and if it's loss 0 like that, and then I need to calculate loss here, to do calculate, to do. You can calculate any way you can, like using Numpy functions. Again, please don't try to use just CPy one-liner, but you can use for loops, whatever, like if necessary, because there is summation. So, and in the top part here, there's loss 0, right? I can even make it like the same way, like that. So again, will be a question to the audience: is this clear? What needs to be done? So, is it clear what needs to be done? Plus, minus. No, let's see if somebody understands what I want you to do. And I will go here. To saprat, kas jādara? Jā, jāizēķina loss kļūda nobīda, izmantojot Numpy vai Python vai nav kādā veidā dabūt, ka tas loss ir izrēķināts.
Kas ir N?
N ir dimensiju skaits būtībā. Šajā gadījumā, ja paraugu skaits, bet šajā gadījumā tad ir 2 dimensijas. So N is the number of dimensions or the number of samples. In this case, this is just the 2 dimensions. So let's see. Do you understand? Because nobody is responding me this time in the chat. This is interesting. Let's see what happens when I come to Riga next week. Okay, if there is specific questions why this is not clear, then please write to me, but I gave you, I think, like everything that I could with this like super dumb sample. Like I believe that, not to believe, but I know that high schoolers usually do these tasks very easily, because I also teach like enthusiasts in high school for deep learning. Okay, tur mēģināt ciklu, tur var izmantot tā.
Es varēju izmantot summu funkciju.
Jā, tu var izmantot MP summu, arī izmantot MP summu, tad būs vieglāk. Vienkārši loss equals MP, bet īstenībā tas nav summa, kur ir dalīts, uzzināt, tas būs MP min, un tad tu saliec iekšā vienkārši. Okay. There are somebody who's saying that they understand what needs to be done. Let's wait for somebody to submit something, hopefully. Let's see. Also, I see that in the classroom, people are trying to do something manually. So again, you can use either for loop and divide it by 2 dimensions. You can use MP sum, MP mean. You can use MP power. You can use the.
But it would be logical if I use Numpy sum.
Yep.
Mean.
Because
I don't understand why I could use
because MP mean, because that is divided by n. You see? Tur viens dalīts ar n priekšā, tāpēc mean. MP mean level. Jā, tā kā tur no nothing too difficult here. You could also use absolute error, L1 if you want, L0, right, or some other strange error loss function. But again, let's stick to L2 this time. Okay, nobody yet submitted the work. Try to do this. Es tev palīdzēju. Okay, varētu kāds ir tālu tīklis, okay, tā, labi, tā, okay, tikai nevis mean, bet mean. Tā kā vidējā. Jā. Un pamēģinu palaist, kā tev izskatās.
Palaist?
Jā, augšā rāna.
Es nevaru palaist, man joprojām lādēs. Tas te torč.
Tu torč noņem nost.
Yeah,
okay, so in the classroom, somebody had the issue that they need to install the additional libraries. So here, the torch is actually the library which we are not using now. You can remove it, and then probably it will be easier to run if you did not install the libraries properly. Yeah, so do that. Vai kā izskatās, kas tur būs nestrādā? Varētu, kas tam nestrādā. Es jau palīdzēšu tā. Aizējam uz rotation. Jā, to vajag šeit ielikt kvadrātiekā.
Jā, es aizmirstu.
Un beigās. Jā, palaid vēlreiz. Tā. Aizējuši turien. So tas, man liekas, caur citu bildu, ka tu vari izskaidri nozēst to paullietu nost. Jā, un ne, vispār nav 10. Jā.
Cik tu gribi teikt? Es varu vienkārši
Zvaigznes.
Zvaigznes.
Jā, Pythonā ir zvaigznes divas. Jā. Vai viņi vairs?
Kas tev pausas nepatīk?
Tikai paņem ieplišķiņu, tagad kaut kur postīties. Tu neesi uztaisījis, ka tev lozu zīmējās. Aiztais cieši to? Pagrāt uz augšu, bišķi uz augšu. Drusci. Zem tētis, pirms tētis ierakstu losu. Stringā.
Šeit los.
Nē, pirms tētis, ne tur. Tikā, jā, los.
Figurējāt?
Jā, bet arī ieliec viņiem nosaukumu los priekšā. Un tad calls viņus. Nē, tad neko nevajag. Vienkārši los. Calls. Vienīgais to losu nav modifinēts. Ieliec augšā pirms while losu. Nē, pirms while. Jā, losu. Equals 0, jā. Paklišķiņi kaut ko. Tagad viņš tādā uzlišķiņi tieši uz pašas header, ne? Tas paliek mazāks, ok? Un tad vēl ko tu izdarīt vēl round?
Kas tieši mazāks?
Nu kā, vērtīgi paliek mazāk
Jā.
Ne, tas tikai nozīmē, cik neprecīzi viņš ir, saprot? Ja
Cik es ir no tās līnijas?
Ne, cik tālu tu esi no šī punkta augšā. Jo tas ir tas, kur mēs gribam ar robotu roku nonākt, saprot? Tu tur ielikt round 2 arī, lai viņam ir nav tik daudz no mūsēs. Bet tas nav, ir ok. So īstenībā es arī, so I also here put around 2 digits, like that. Okay, we'll see if somebody finished this. Okay, nobody submitted, unfortunately, but in the classroom people did succeed, so this is good. So again, if you do it yourself, please do it yourself. Submit it. I will be very happy for that. But otherwise, I will show you here. So MP, either I can do MP sum, and then as it was divided by 2, like that, or I can do just MP mean, and then I can have just exactly the same equation. And if I'm using things from the Numpy and then later from the PyTorch, it makes life very easy, because even though these are Numpy arrays or vectors or matrices, I can do mathematical operations with them just using the same operations as they would be like floating point numbers. Like I can do the minus, I can do the power functions, I can do anything I want with number functions if they are Numpy arrays. So this is very powerful. If these would be just a simple lists, like for example, if I would write the list like this, 0, 0, 1, 1, then this would not work at all, because this is not derived from the inherited from Numpy array, and this will be just a simple Python. So this is not actually simple Python, this is from Numpy operations. So minus operation and square operation. And the minus operation works only because these two are the same size. Last time, when we talked about linear algebra, I showed you these examples explicitly, that you can do these with Numpy easily. And you can also do this or any other mathematical operation. So if I run this now, let's see how it looks like. So here the error is 0, and here the error is 6, 7, 8, 9, and it goes exponentially higher. So if I click here, there is 32. If I click here, it's 0.2. So it is exponentially getting higher because the loss function is exponential. So yeah, so this is good. So let's move back to the whiteboard. I hope you managed to write this small equation yourself, because it's not really hard. Then let's move to the next step. The next step is finding the direction where to move, where to change the thetas. So this is kind of important stuff here, because our equation basically depends on two variables, and these two variables are theta 1 and theta 2, and we need to find out what is the correct direction where to change them. So we have these two variables. We have theta 1 here, theta 1, theta 1, theta 1. This is allowed to change, and the other one which is allowed to change is theta 2. We can also tell that we just want to change one of them, or we can change all of them, or we can change also even t. But these are the only ones we can change. We don't change the function structure, we don't change anything else, just those values. So, but we need to know in what direction change these values. Now, how to do this? So this is done by stochastic gradient descent and partial derivatives. So SGD, stochastic gradient descent, stochastic gradient descent. So it's and partial derivatives, and the way how this works is following. So if I would like to change theta 2, I would apply this equation, and we will do this ourselves very soon. So basically, if I would like to change theta 2 so that I would reduce the loss, and there is a key here. So the key is following. So if I want to reduce the loss value, I use minus sign here. So this means like make loss smaller. If I want to make loss bigger, so this would be minus. If I want to make loss larger, then I would use the plus sign there. So this is very important, one mathematical attribute. Then also what we have here is some step size. So we have here the step size. So this is just a delta, a small delta value or step. And this part, this middle part is the main thing, how this whole operation works. So and this one is the partial derivative, or you could say derivative. I really don't care. So so the derivative of loss function with regards to theta 2. We also will have for the theta 1, and if we want, we can have it for the t value as well, if we want to have extending arm. So what we have here is, let's say, theta 2 here, theta 2 here, and with regards to theta 2 here. And loss function we already have, and the whole upper part is just equal with y prim, basically equals with y prim. So we should then plug it in and calculate. But to do this calculation and to enable so that robot arm starts to moving, we need to go step by step. So to do this green partial derivative part, I believe we should a little bit refresh in our memory how basically these partial derivatives work in the first place. So let's see. First of all, let's do something like this, and then I will show more things. Okay, now let's do it from the very beginning. So partial derivatives and derivatives itself, this is no rocket science, no magic, no nothing. This is really dumb tables. Basically, they are very dumb rules. As previously I showed already, these things which we do is very simple. So these are the differentiation or rules. Basically, you have the main rules that you need to know is constant rule, power rule, chain rule. Basically, we could write them out. If you know those rules, you can calculate derivatives of 99% equations. So if you know this, and this, 99%, like maybe 90% equations are easily done. And you could actually product rule and quotient rule is somehow, I believe you could also get from the combination of previous ones. So, but anyway, so these are the ones you should remember. And then also, because we are using rotation matrices, right? Rotation matrices, then we also would be good if we know these ones, which are the trigonometric. So the sinus x with regards to x is cosinus x, for example, and here in the power rule it's the x power of n with regards to x is n times x with the power of n minus 1. So these are the basic rules, right? And then if you follow very simple basic rules, you should be able to do also some very simple operations, and we could try to play around with these and see how well you understand these basic concepts. So I want to show you also another thing which is also listed here. So first of all, this will be the first equation which we could tackle. So think about, please, also in the live audience, you could write the answer basically in the chat. And I would highly recommend for you to try to do this manually, like either on paper or I don't know, like in some comment code or something. But really don't just you know, use some automatic tool, because this will become more and more intense. So so what's up here? So I wanted to highlight another thing. So let's take some color. Okay, other color. Can I take another color? I don't know, orange. Okay, let's take some pink color. Ah, no, it didn't take my pink. Okay, cool. So yeah. So here, what I want to show you is this is a partial derivative, this is a simple derivative, and this is the simple derivative or partial derivative. All of these are the same thing. So this means, all of this means exactly the same operation. And in mathematics you will see in the following lectures that mathematics become so fuzzy. Basically, it is not always, the people that work with mathematics not always are consistent. They write things in crazy ways, like they invent ways how to write equations in publications. So you just need to understand the basic logic behind it, and then you try to replicate those equations. So it's not like in a high school where you have very defined way how you write things. In the calculus and higher mathematics, they write it as they want, basically. So and here what we see is also, so here's the derivative, right? So this is exactly the same thing as here, and here's also a derivative, if you see. And of course this is also a derivative. So my question comes back to this. So maybe you could calculate what is the right answer here. I will look myself. So yeah, I think I got it. I mean, not from this equation, but what is the right answer here from where's the part? Okay, let's see in the chat. No answers in the chat. What's up with that? So, and we are losing people, so that is not a good sign. But I hope that those who are listening understand that this is some great stuff, and if you get through my course, you will be able to do crazy things. So the things which people actually pay money for, not the simple dummy prompt engineering, which we will also do. So you will be able to build models that enable prompt engineering, not just doing the prompt engineering. So yeah, so the f of a dA. So what is the answer there? Can you give me one? 4a. 4a. You say Mallet. That's good. Mallet's good. Yeah, the person the persons here in the classroom answered correctly, and so yeah. So if we try to split it out, maybe I should also use LaTeX. This will be easier. Let me think. Okay, I can try. It's just I've already started thinking about the next equation. Okay, but so there is the f of a with d of a equals the 2 times 2a, and here is the 2 minus 1. Plus this becomes 0 because there is no a attached to it. If there would be multiplied by a or powered by a or some other function by a, then it will be different story, but there is very simple. Or even if the other part would contain different variable than b, then it's also the same. So and then the output is 4a basically. So yeah, so that's that. Now let's look at some other equation. Okay, so yeah, I think I need LaTeX. So let's see, LaTeX it. Again, last time I already used a lot of LaTeX editor. So this is a mathematical editor used by scientists, and this is something that I highly recommend people to learn as well. So this is the LaTeX editor. Let's drop in some equations. Okay, so there will be these ones, and I don't like that this one is defined like this. So I will define it like h of a equals something. Okay, so this I like better. Okay, great. So now it becomes more interesting. So I have this kind of chain of equations, and basically you will, oh right, something is not right here. All right, I understood what is not right here. Okay, now it, okay, right. Okay, let's start step by step. So here, this will be the first equation. Everything is right, but I just want to show you. So if I have this equation, and then I ask somebody to do the frac of h, a, and partial, or it could be just d of a, and equals something, then you have a couple of options. Like the dummy option, which I highly not recommend, is to try to open the equation and then calculate the derivative. This is not the way how mathematicians do it. So this is how the way how high schoolers do it, but not the mathematicians. So how mathematicians do it is to decompose the problem. And decomposing the problem looks something like this. So what I could do is I could have the set up some kind of situation like this, where I have, let's say, the inner equation, which is f of a, and then I have the outer equation, which is g of, like basically g of b something. And then how I would define it is something like this. Instead of having h of a, I will define it like, so this will be g of f of a, like that. And then if you would look in my table, which I showed you just in a second, even I can show you again, there is something for it. There is something already given. So if you look at chain rule, so if you look carefully here, this is the same stuff going on here, see? So, and if you do this, then everything becomes super easy. So, yeah, I would encourage you to try to do this yourself, but we could start doing it together. So if somebody wants to answer the final result in the chat, which it's interesting, the previous answer was not given at all, but let's see if somebody can do this time. So sh of a dA. So if somebody wants to give the answer, try, but I will start showing stuff how to do this. So to decompose the problem, then it becomes much easier. So you could just then use the chain rule, and chain rule is used very often, and then I will try to highlight why it's so important. It will be essential for deep learning. So the deep learning models, these amazing transformers and so on, they all rely on chain rule. If there would not be these properties, nothing of that would work, because they will not be able to open equation like with thousands of variables. So here, let's see. So this is the first part. So h of f. So let's see. So the first part will be a frac of so the g of f, and here it will be from partial of what is coming into the equation. So this is not the variable, but this is the variable that's coming in. So, and this is something to think about, because often students do not get it, that this is not like the variables itself are dynamic. There is no, they are not like tied to specific like symbol. So here, if I run it again, so it looks like that. So what I want you to imagine is that the bottom part of the equation, where there is this f of a, could be some kind of temporary variable. So maybe I could show this on the whiteboard. It makes clearer then how to think about it. So how to think about these equations is following. So if you go here, oh right, it did not copy what I wanted, copy JPEG. Okay, now it's coming. Okay, great. So how to think about it is this. So this part could be just replaced by some, in your head, with some kind of new letter like C, or C is maybe not the great, because C is already something that we used. Let's say K. So there is a, let's say D of K of G going into K. So this is basically that's what's happening there. You don't need to be confused seeing that there is a function of derivative. So these are dynamic variables. So basically at the end, this is not like physics formulas. Physics often in the high school, you would have the result of equation like this is your answer. This is not the way. So in mathematics, these parts, all of these elements, except the functions themselves, everything of this, these are numbers. Number. They are changing every time. When the robot arms change, those numbers also change. So as soon as we get here, now the problem becomes super simple, because I believe all of you should be able to do the first and second derivative here and then multiply them together. And if we are talking about matrix multiplications, if matrix multiplications, then this is the dot product. If this is just the scalar values like I have here, then this is simple multiplication. So we got so far. I believe you should be able to finish this equation, hopefully. Any ideas for the answer? I believe maybe it's not as simple. We'll see, but you could try to write it somewhere. Okay, nobody wrote it in the chat yet, so we'll see. Okay, so let's try to calculate ourselves here. So okay, so let's start by the first part. Okay, so the G part. So this is kind of simple, I guess. So this is the f of a squared, and in front we will have 3, so like that, and then there will be the so this is the f of a. So and then there will be the c dot, and the other part is the 3o. If it's from the a, this will be a little bit more painful, but we will get there. I did not notice. All right, no, this will not be as painful as I thought. Okay, this is good. So there will be 3 times 2, which is 6, a, and then in brackets there will be 2 minus 1, like that. So this will be so far. and plus 0 because the, oh no, there is other one, plus 1, a 1 minus 1, like that. Okay, cool. I believe so far it should be correct. If I'm mistaken, let me know. So, and then the final result would be 3 of f of a squared. Oh, right, and there is a multiplication, unfortunately. So, c dot 6a plus 1, like that. We could open the, so basically let's not open it fully, but basically this is what we get. So if we plug in the scalar values, we would end up with the right result. So that's so far. If something is not clear about this part, about these partial derivatives, and why it's partial, it's, well, maybe let me show you some other example about why it's partial. So let's say if we have some h variable here, function, so we have a, let's say 4, right, 2 plus b, ba plus b 3, like that, something like that, yeah, equation like this. And if I would like now to calculate something of it, so frac b and partial a, for example, so this would be one variable and this would be another variable. That's why it is called partial, because we have two variables there, and each of them are slightly dependent of each other, but at the same time, like basically, if you use the rules, you will eliminate each other's. So for the first equation, what is the answer? What do you think? You don't know? Okay, no worries. So the first one, but this is good that we are doing this now because it makes clearer. So the first one, it's 2 c dot 4 a 3, right? So, or 4 minus 1. So this is the power rule. Again, I'm not doing anything magical. All of this is what I showed you before in the table on the whiteboard. Table on the whiteboard gives you the formula how to become from one equation to another equation. So here this will be 1 minus 1, and this will become 0 because this is not containing a. So basically this is the answer. And then for the second one, I believe you're also able to do the equation, right? Yeah? You don't know? No, oh, right, there is more mistakes. Thank you. So there should be actually b. So this would be correct equation, but regardless of that, the idea should be clear. So the other one, you know how to do the other one, right? Yeah. Nu, tad kā tur būs? Tur būs pirmais, būs kas? 0, yeah. First one is 0, then yeah, un tas būs 1, that will be 1, and then it will become a, yeah. And then the last one?
0.
No. C. B. 3 B 2. Yes. That's the right way. So yeah, if you follow carefully along, this is how it works basically. So and this is not, if you think about it, look at it carefully. Really, there is no difficult things. There's just carefully, slowly look at the equation. Think if there is some multiplication or power function aligned with that variable, then it is tied together. If it's not tied together, then we can move on further. So let me show you in the whiteboard again what I'm talking about. So this is the equation which we just did. This is the equation which we just did. This is again what we did. This is again what we did. And all of these we did with these rules. So these 3 rules. So constant rule means if you look carefully here, there is the d of x from equation where there is c there, which doesn't make sense because c is not existing there, so that's why it's 0. If there is b, a, f, whatever, it's always 0. Then for the power rule, again, it's very simple, times n minus n minus 1 in the power. For the chain rule, again, if you make this onion, so there is this onion of the functions, then you remove the first part of the onion by the function that's coming into the first part, and then you multiply it by the second part of the onion. So, and if there would be more parts of the onion, you would just keep multiplying them. So this is kind of the basis of partial derivatives. And basically, if you have this, now we understand what is the partial derivative. If you are able to calculate this guy, then you are able to determine the direction on which to go with the loss function to reduce it. So again, let's look at this one more time with some visuals, and then let's try to do the final equation, and then we'll implement it, and you will hopefully understand. So the visual is this. Oh, it did not copy me the stuff. Right, everything is hanging copy image. Okay, so this is the L2, right, parabolic function. So regardless if my, okay, right, so this will be the, on the bottom part will be the y minus y prime, yeah, and on the y part there will be just this stuff squared, right? So, or L2, right? So, or mean square error. So that's what we have there. And the equation itself is also clear. And the process by which we will able to, remember we had this to determine how good is our robot position. So, and the process how to get there where we want to go is done by that small equation which I showed you before, which is this one. Let me show you. So the process is done using this one. And so if you look at theta 2, we will need to do the same for theta 1. So then if we start our optimization, this is called stochastic gradient descent optimization. If we start here, right? So this is our initial distance from robot arm, and this is far away, so this is not good. So what we will get by this variable, it will be literally multiplier by which we need to move in different directions. So basically this will say go up or go down. So this will say go there or go there. So what do you think, where it will, in what direction it will go? So okay, that's down. Yeah, it will go down, but you have a right comment. So it depends on having also that minus sign in front, but yeah, it will go down. So let's imagine next step. So next step we are
where is target?
Target? So we want to minimize function. So if you look at this equation, what do you think? What is the target? The target is 0. You want to have no mistake, right? So you don't want your robot arm to go in the wrong position. So then I'm going the next time. So and by the way, these jumps, you see there are these jumps. These jumps are alpha, or these small like steps, right? So and then the next step will be closer to the 0, right? So we're going there, and now my question will be also in the chat. So let's see. So where will be the next step? Will the next step be here or here? Let's say or maybe let's write it here or here, for example. So and this will be let's say A position, and this will be the B position, the other one will be B. Oh. So yeah, you also think here in the class, but I will ask in the chat as well. So where will it go next, A or B? So asking in the chat, again, you should just look at this and you should be able to tell it immediately if you kind of understand or have intuition about it. But yeah, so what do you think?
It's a difficult question.
Oh, it
Could go.
Okay, you think they
could be because it's look.
Okay, but
Here's
no, but there's no. This is not. So you're thinking about it because the y could change. So let's think about in the way that, let's say that the y value will not change. So let's say that the target is not changing. So this is a constant. Y is constant. Only thing that changes is the other part. So everything that is related to y prim or the thetas, basically this is changing, this is changing, this is changing, this is changing. So if you think it from that way, then it's not difficult. Kam tuvāk?
Tuvāk tam nulli.
Okay, let's see what other things. Okay, still A. Okay, somebody thought it's still A. All right. Yeah. So the, I don't know, like somebody saying the studying, but again, like, okay, let's do it different. Okay. So do you think A? So just a second. So first of all, I see in the chat somebody wrote that this is difficult. So first of all, like if there are people who are not capable with mathematics, so there might be option that you write to me in the email. I probably sometime later this year will have like an easy course for business people. Maybe then I can transfer somebody there, but they will not be able probably to do in life really like AI work. Basically, with those who will manage to do this course, will be able to actually do thesis on AI. If you don't do this, then you will have really weak thesis in AI. Basically you can do business people AI thesis, which doesn't, like, if you just take YOLO model and make a classifier of the like segmentation model, this is not nowadays valid thesis. Basically everybody can do it just taking. So that's just a comment for those who say this is very difficult, but for those who want to try to learn this, I encourage you not to be scared. It's you just need to go through this slowly once again, and they also post materials. And like if you, just from the experience, if you don't give up, you eventually get it. So like a lot of people said that this will be A, but this will be actually B. But why it will be B? So if you look at there is a reason why it's B. So if you look at this axis, like there is the 0, right? So this is on the top, right? And this value is higher than this value, see? And basically this loss function will always try to go lower, not higher, okay? It will never do this chick. It will try to go down. And of course it will jump from one side to another side, but it normally do not jump up very much. So that's one part. Okay, that's one part. But then the most important part. Now let's jump into the most important part, which is the actual final equation which we need to implement so that robot arm becomes alive. So the final equation looks, so I believe I specifically did this from theta 2 because it was more simpler, but I will show you both equations, I guess, because if you already see that some people don't feel comfortable with mathematics, I need to show more, I guess. So there's the, so this is the basis here, right? So actually, what I'm trying to understand, what I want to show you is that the loss function here actually contains y and this guy there, chicks. So it already means that we see there is an onion there. So there is the first part of the onion that needs to be calculated, and the first part of the onion is actually the loss derivative of the loss function itself. So yeah, so the derivative of the loss function itself. So what I mean by that is this. So the first part of the onion which I need to calculate is not to jump in directly in that guy, but to do this. So let's see. So the first part is this. I need to calculate a derivative with regards to x here, so which is with regards to y prime, like this. Oh yeah, so this is this, and this is this as well. And here, how to do this? Ouch. So yeah, how to do this? So this is actually, I usually ask to do this the students themselves, but it kind of feel that maybe you need some help here. So let's see. So this will be this. Right. All right. I jumped a little bit ahead. So no, this is not what I wanted to show. Right. Let's see here. Okay. Cool. Yeah. Okay. So I have this, basically it boils down to this. So there's the summation part, the average part, I can drop it in now because that will be just, you can like think of like constant multiplied, whatever. So but what is important is the middle part. So and the middle part is also not super trivial because even though it looks very easy, you have two options. Either you open the equation, which is actually not too hard. You could open the equation, but again, mathematicians don't do it. Or you can use the chain rule. And if you use the chain rule, then it actually looks something like this. So after using chain rule, it looks like this. This is the same thing which we did before. Exactly the same with the G, H, F. It's just for the real use case. And then if you use that, then the next step becomes super easy because the next step then looks like this. So the next step is the top part goes down. There is the 2, and then there is 1 minus 1. Actually, we could write it down here. Oh no, 2 minus 1, sorry. 2 minus 1 here, right? And then the other part goes like this because there the first one becomes 0. We could actually put this as a bracket like that. So the first becomes 0. So and this is then the answer. And then the final answer for this part becomes minus 2 like that. But there's a really fun thing here because if you change the order of y and y prime in the L2 equation, like the summation equation, then nothing changes. But if you change the same order in the derivative, then everything changes because it becomes minus 2 or 2. So you need to be super careful always with the order of the variables. So let me show you here the same equation with some annotations. So, oh man, okay, this is uploading. Okay, cool. So here, so what I wanted to show you is that in this part, you can have any kind of, you can have it y minus prime or y prime minus y, but as soon as you do this, then the order becomes super important because at the end, you see in this part, there will be minus sign in other part, so there will be basically no minus sign there, and then this one also changes. So the derivatives and orders of the variables super important. So, but we already have, so we have one Lego piece done. So this Lego piece is very valuable. I recommend you to remember this Lego piece. So this one equals that. So that is the first Lego piece ready. So, and why I'm saying this is the Lego piece, because if we go back to that equation, and I promise you in like 5 to 10 minutes we will start coding this, and you will see that this is not that scary, hopefully, because again, depends on the perspective. This is that equation. So what we have here, we will do the de-onioning, so to say. We will remove the layers of the onions. So if we want to remove the first layer of the onion, what we actually need to do is very simple. So the removal of the first layer of the onion looks like this. So it is this thing, c dot multiplied by derivative of, actually I can rewrite it out, it's not difficult, so let me write it out. So this will be that c dot frac of the f by the d theta theta 2, I believe, if we are targeting theta 2, yes. So that's that, so like that. And if you have more functions on top of other functions, you keep doing this, multiplying. And now to have the derivative of that theta 2, it's also super easy actually. So you think maybe it's not, but it is really. So the first part we already calculated, so you don't need to worry about derivative of y loss with regards to y prime, because that is already calculated. You have the equation ready. I showed it you before. So but the other part is also very simple. So what happens? So the first one becomes 0 because there is no theta there. The second part becomes, so this will become frac of r theta. Okay, that actually also, right, I'm a little bit, something is not cool here, so that is, okay, that is, no, everything is cool here. So that stays the same. So this is the constant, sorry, that is the constant. And then the next one, oh, this is even simpler than I thought. So then the next one becomes frac of r theta 2 with regards to d theta 2, like this. So this will be the other equation times t. So like that. Hopefully, let's see if it works. Okay, cool. I think it is like that. So and what is there? This matrix operation, rotation with a d of 2. This is super simple. You need to use trigonometric rules to make a matrix that is derivative matrix or Jacobian matrix. So this I will show you in a second. So that part is super easy. And then to have another equation. So this is, if we will implement only this one, the robot arm will move only by one angle. If we want another angle working, then we need another equation, which is theta 1, like this. And this again is the same stuff as before. So we have this loss function stuff multiplied by the internal part. And the internal part will be, so in this time it will be, that one is multiplied. So maybe I have somewhere already pre-calculated because I don't want to write it too long. Okay, I have it somewhere. R theta, where is it? Do I have it somewhere? If I not pre-calculated, I can write it myself, but it takes a time. Right, let's write it ourselves. So there should be theta 1 So this will be theta 1, plus the other one again, multiplied by the constant. This part doesn't change because that is the constant. Chicks. So like that. Great. So I believe that is it basically. Even though if you think that this is complicated or whatsoever, don't give up on this, because again, the more you will do it, the more clearer it will become. The next time we will do the same equations, but in a little slightly different manner using the neural networks. And neural networks then also will open you some new possibilities that will help you to understand this better. And we'll now implement this together in the code as well, and that will also help, because if you see the same equation in programmatic code, it helps you to understand. So let's see. So this is the robot arm forward pass, and all of this other parts is robot arm backward pass. And what we actually calculated is that this part says like how much I need to move the theta 2 angle, and this says how much I need to move theta 1 angle in order to achieve the position where I want to go. And our position where I want to go is y. Y is the target position. And this part is pre-calculated. This part we can make easily, and then these other parts are just simple mathematical operations. And how I made these equations, as you saw, I just used the derivative table variable. So I used exactly these rules, and we will use also these rules to make these rotation matrices, rotation calculations. Okay, so that's it. So, and then let's see if we jump back to the code and make this work. This is really nothing rocket science or so on. So if we go here, so we have rotation, right? Let's make d-rotation. So this will be the derivative of rotation. So d-rotation, like that. So we'll make this one. And this is, again, really, really simple, because we will just need to swap around a little bit those equations. So let's see. So if the c, so what is that? So the cosinus becomes minus sinus. So I put here the sinus. This will becomes minus cosinus. This becomes minus sinus, and this becomes cosinus. And this is how I change these values, is just because of the table. So again, that is the reason why Wolfram Alpha is able to do partial derivatives so easily. It is because this is very simple, because you just use the tables. Basically, you can just look at if this matches the table, that's it. So it's nothing hard. Okay, so we did this. Let's move on. So then the next part. So let's calculate, pre-calculate the rotation. So dr2. So these will be d, like that, right? And now we need to do this automated like stochastic gradient descent optimization. But to do this, we need to first calculate the d theta, right? This part. So to do this, let's calculate d loss as well. D loss is super easy because I already gave it to you. Minus 2 times y minus y prime. So this equation was given to you on the Jamboard as well, and this one is also. Okay, and then the last part is this d theta 1 and d theta 2. So with regards to loss function, so d theta 1. So this is that, you could think of it as a direction, so there's direction. So where to change the variable and how much to change it. So there will be this mean coming around it, and there will be d loss, and I could use here the dot product, but this is no sense because the D loss is already scalar value. That's why I'm using the simple stuff here. So and then the next part is the other part of the equation, but I need to check it. So this is d theta 1. So is it correct? Let's see. So I can just write it on the spot, I guess. H, here is the HR21, right? Here it is. Okay, I believe so. So here there should be D R1, right, which is the one first theta. Yeah, it is the first theta. Okay, D R1. dr1 times t that is there plus dr1 r2 at r2 at t. Yeah, I believe it should be like that. So yep, at least it looks like that. So to make it maybe clearer at this point, we could just move this h here, so you see that in the mirror image that you have here, r t t r r2 r2 t t, everything aligns up here. So, and then for the T2, this is the same equation, just different focus. So the only thing that changes is the target variable, the target focus. So this time we have the first part becomes 0 as we draw in the class, and the second, whoa, but there is a plus there, so there should be around this thing. I forgot about this thing. Okay. So there should be that part. Okay, and here this will be dr2 and there will be r1 like that. Okay, and there is a t. Yep. So this is the second part of the equation. And then oh right, the h is missing now here. Okay, let's use the h. H is the same thing as this thing, it doesn't care about it. Yeah, cool. So, and then the last thing is actual movement of the robot arm, which is based on that stochastic gradient descent. So we have alpha. Alpha will be small incremental step e minus 2. And then we will change the theta 1, based on this partial derivative. So d theta 1 multiplied by alpha. It is that simple. Basically, this is extremely simple as soon as you start to getting the basics here. So you have basically the rotation, you have the derivative of rotations, you have equation, and you have derivatives of the equations based on the variables which are changing. We are not changing equation itself. We are changing some inputs. And what are the inputs? We have the thetas are the inputs, the y where we want to go, and that's about it in this case. So yeah, I will make a screenshot of this, put also this on the whiteboard, and demonstrate hopefully that it works. As you know, when you do live sessions, maybe sometimes we have some bugs, but this is also good learning to debug them. And the cool thing is that what I'm showing you here is exactly the same mathematics that are used for ChatGPT and any kind of models. So let's see. So let's run it here. So if I try to run it, okay, it seems to be working. So see, it's actually working very naturally. So it's trying to extend the arm to that point. At least I'm hoping that it's working. So it will be interesting to how it will fold here. See it slowly folding to reach this goal. Can try to do this. So now I will try to extend it. So now it's extending. And by the way, the farther it goes faster. You can even see it, that when it slows down, this is because of the loss function. The loss function is curved, and this is making it slow down. Basically, if I would make a L1 loss function mean absolute error, it would go faster. So, but you see, this is very natural way how this works, and we did not calculate any kind of geometry or so on. We did this completely using partial derivatives. So the way how to look at this is the same way as so it will be very slow because it needs to fold, but it will work. We actually could try to do this like that, challenge this. Okay, it will work. So how to look at this? You have the input X, which is in the bottom part, and the output Y, and the red one is the target state. So imagine if you want to have an image classifier that is classifying cats and dogs. So you have the image coming in, and the output is the, for example, this position means cat, and this position, for example, means dog, and the robot arm or your model, in other words, will go to that position, which is the right position. So this is basically the basis of this mathematics. Did you manage to work it out? Okay, great, excellent. I really hope that those who are remotely joining also manage to work it out. Next time we'll look at the homework. You'll have a little bit more time to finish it. The next homework will be to add another segment here. So we have a 3-segment arm. So this is not difficult. Again, don't be worried about it. Just try to add another segment here. So what it means is that you will need to do a little bit of mathematics, but not too much. So you will have theta 3 as well. So you'll have these things. And you will have another point here. So this will be point H, and then let's say point K. You need to calculate where the point K is located. So this is easy because point K is already here. And then you will need to have Y prime, which is based on the theta 3 with this next step. And then you will need to have another equation here. And that's it, basically. You will not have, basically literally, you need to add 3 lines, and you will be able to do three part robot arm. So that is what I want you to do for the home. And next time we'll start jumping into proper deep learning models, that very simple neural networks by hand. And we will build up on that and make sure that you are able to build your own ChatGPT at the end of this course. Basically, it will be even more complicated models, because actually the transformer GPT architecture is very simple. There are even cooler models nowadays. So that's it for today. Follow next lecture next week, Wednesday in Riga. 6 o'clock, 4 o'clock probably. Maybe I will do a little poll. So if you go into Whiteboard, right? I mean not Whiteboard, in the Moodle. Maybe I will do a poll for the timing, because I know some people the 4 o'clock is not good time. So we'll try to see if everybody wants to go, like, let's say 6 o'clock, then we could meet 6 o'clock in Riga, and would be happy to meet people who live in Riga as well. And yeah, let's keep digging in. And if you're super not comfortable with maths and you don't want to do actual scientific work in maths, just like some kind of business stuff, so then you can reach out to me. I could try to put you to different course maybe, but if you want to do thesis in AI, this is the only way to go basically. So that's it. Thank you for joining us. Bye bye.